Instrumentation and control systems. This is Unit 16. We're going to be looking at this last section with the hints and tips of completing the learning outcome 4 of the second assignment. So what we want to look at is applying the predictive values, and this is where we're going to be spending a lot of time looking at simulator. It's when we put in a predicted value, and hopefully when we get this, it controls the system so that when you are controlling big conveyor systems or automated systems, you've got the stability from what has been set when the input signal comes into it, and then hopefully that we got some improvements. So let's make a start. We're going to be looking at Skylab Simulator. This is what is known as open source. And there is use of it for mathematical engineering and scientific applications. Well, we're engineers, so let's put into it. It's going to be for engineering applications. You can also use it in 2-dimension, 3-dimension visualization. And of course, you've got to optimize the algorithms, statistical analysis, signal processing. That's an important part of the simulator, and its Exos simulator. So this Skylab, we're going to be looking at it shortly, but let us go through some of the functions. Before we open it up, I want to just explain a bit about it. So that is the main screen, a bit like Windows, where you've got the various icons, and it'll come up with that. What you want to be able to do is when you build like a block diagram, you pull these along, and then you set these up, and then of course you have to include the various parameters. So let's look at some of the functions. CLR, as it stands for continuous transfer function. Now we can see it's very mathematical based, 1/1 plus s. So we're looking at how to transfer the function, describing this one here as part of, it can be described as a low pass filter. Now we're going to look at the PID, a proportional integral differential controller. Here's the PID. This is the main man there. You can see it as being the one that's going to be used to actually measure. We'll take everything through here, and this is the controller. It will be used via 3 constants, and then we have a KP, which is a proportional constant, the KI, the integral constant, and the KD, the differential. And these are all various parts of which work in a more mathematical way, which operates within the actual electronics. The summation, well, as you see here, we've got the summation sign here, the Greek sign for summation, and this is where we'll be adding up the inputs. Of course, next thing we have is a multiplexer, and you can see the word mux there. This is where you take 2 signals in and you get 1 signal out. And a C-scope, just like an oscilloscope, that will display the input of the simulation. As you can see there, we've got a sine wave, and that's showing us the C-scope. Now, like in any piece of electronics and visual stuff and computers, microprocessors, you need a clock. So there we have the clock, and here we have it. It shows us a fascia of a clock. The next thing we have is what's known as a step function. As we see here, this is a step function. It's quite easy to understand, and this is by setting up the a pulse, a sawtooth, or a ramp, and you want to create as part of the control system. We're now going to move on to Skylab Simulator. In the next part of this video, we'll see how Skylab works, and we'll look at an example. We're going to be using the Skylab program to simulate a PID controller. What we can see here is it's an open source program, and we're using UniCourse as a block diagram editor. And we're just looking around at it now, where you can see me starting it off. So here we have the application. What we're going to see here, bringing up, you'll recognize this on the right hand side. Here are all the icons, and what we'll be able to do is start to bring things in here. So we've got the first block here, and what you need to do is just make sure that you follow it. The PID is brought in, Now we want to look at the summation part of it. That's brought in. Well, just bringing in the blocks. That's what you do. The multiplexer next. That's brought in, and we're going to be eventually going to be connected up. Here we have the C-scope, which will be the oscilloscope, and we got a couple more things we want to do yet just to get it right. And now we're looking at the clock. Of course, we need that to be able to get it to run, and we also need a step function, which will be the signal, which will be on the input side. Now we start looking at connecting it up. We move them around, make it look more tidy, set it out as wide as possible, just so it's near enough so you can connect it all up, but as far enough that you can actually see a nice display. And you can see it's fairly straightforward just by moving the connections together, just by using the cursor and just bring them across, as you can see here, connecting them up. And then you keep coming on here, the PID, that is connected up as well. We're nearly there now, and finally we have the step function, the ramp there. You can see that connected up. Looks a bit up there, but we'll leave it like that for the time being. Connect that one there, and you will start to connect up from the various other blocks. Here we've got now the feedback loops coming into it. We've got the second one here from the multiplexer that's been fed back into there, so we've got the two on the plus side and the minus side there. And now we're going to set things up. We need to put the various parameters in, and we've got the integrating time. We've got that set up, which looks fairly good. And we're going to set up the scope, make sure that's correct, so that when we see the waveforms there, the two waveforms there, the step up there, and the actual output signal, they all look fine. Press OK, and that's great. Now we've got it all set up. We just need to put in there the values as required. I put the numbers in, 45, I put on the 4 there, we'll leave it at that, and then we put denominator, and we see that the syntax must be correct, that must be always okay, and that's it. If you get that, you do get an error, so we put that in again, make sure it's connected up right, put the right syntax in, press the OK, and then we're fine. So it all looks okay now. Just rechecking it, go back to the PID here, set the values as well. We're going to look at a couple of different versions to it. Press the OK, and that's what we've got there now. We've got also the input signal there, that ramp, step time there, and that looks okay, looking pretty good. Now we press the arrow to simulator, and let's see what happens. We're going to press the simulation. It takes a bit of time, and here we have the waveforms. As you can see there, you've got the ramp there, and you can see the oscillation out there, and you can see what happens with the output. And look, it looks pretty good there. And then we'll change it again, see what happens when we change different values, and see what happens. This time we're changing it to 10, and let's see what's going on now. The frequency will increase. There, the speed up there, you can see the step up there, and it's there working quite nicely. And so the actual simulation is working quite well. And we're looking at one more value. Change that deviation to 2. Let's see how it looks. Get it back again to play, to simulate. Let's see what's going on. There we can see there, it's improving even more as well. So we're getting it a lot quicker.